Let's dive in. You've seen these tiny, colorful dumbbells on circuit boards. Those are resistors. They're the traffic cops of electricity, controlling the flow so things don't fry. Without them, circuits would be chaos. A resistor simply resists the flow of electricity. Think of it as pinching a hose to slow water. This keeps sensitive parts like LEDs and chips safe. By picking different resistor values, we control how much current goes where. It's the foundation of every electronic device. Next time you see a circuit board, remember, those little stripes are keeping everything running smoothly. Understanding resistors is your first superpower in electronics. Ready to learn their language? Let's get started. Why not just print numbers on resistors? Simple, they're tiny. Printing readable numbers would be impossible and expensive. Instead, we use color bands, a universal code. No matter where a resistor is made, brown is always 1, red is always 2, and so on. The bands wrap around, so you can read them from any angle. Painting stripes is fast, cheap, and reliable for mass production. This keeps electronics affordable and efficient. The color code is a brilliant global solution. At first it looks like a secret message, but it's easy to learn. Once you know the code, you'll read resistors in seconds. It's a skill every maker needs. Let's crack the code together. Here's how it works. Most resistors use a 4-band system. Look for 4 colored stripes. Read them left to right. The first 2 bands are digits. They give you the base number. For example, brown then black means 1, and 0. That's 10. The third band is the multiplier. How many zeros to add? If it's red, add 2 zeros. 10 becomes 1000. The fourth band is tolerance, usually gold or silver. Gold means the value is within 5%. Silver is 10%. No fourth band? That's 20% tolerance. For most projects, 5% is plenty accurate. So, brown, black, red, gold is 1000 ohms, 5% tolerance. These 4 bands tell you everything you need to know. It's a simple, powerful system. Let's see how to use it in practice. Grab a resistor and follow along. Here's your decoder ring, the color code chart. This simple chart is your best friend when it comes to understanding resistors. It's like a secret language that unlocks the values hidden in those tiny colored bands. Whether you're a beginner just starting out or a seasoned electronics hobbyist, having this chart nearby will save you time and prevent mistakes. Print it out, tape it to your workbench, or even keep a copy in your toolbox. Some people like to memorize it, but there's no shame in keeping it handy for quick reference. It's a must-have tool for anyone working with electronics. Each color on the chart matches a specific number. For example, black is 0, brown is 1, and red is 2. These are the building blocks for reading resistor values. Orange stands for 3, and yellow is 4. As you move down the chart, each color represents the next number in the sequence. Green is 5, blue is 6. These colors are easy to spot and help you quickly identify the value of each band. Violet is 7, gray is 8, and white is 9. With just a glance, you can decode almost any resistor using these colors. The first 2 bands on a resistor use these numbers to represent the first 2 digits of the resistor's value. For example, if you see brown and black, that's a 1 and a 0. The third band is a little different. It acts as a multiplier. The same colors are used, but now they tell you how many zeros to add. Black means multiply by 1. Brown means multiply by 10. Red by 100, and so on. This is how resistors can cover such a huge range of values, from just a few ohms to millions. With just these simple color codes, you can read resistors of almost any value. It's a clever system that packs a lot of information into a tiny space. The fourth band is all about tolerance, how much the actual resistance can vary from the stated value. Gold means the resistor is accurate to within 5%, silver means 10%. Sometimes you'll see a brown band, which means 1% tolerance. These are used when you need extra precision, or you might spot a red band, which stands for 2% tolerance. These are called precision resistors, and are used in circuits where accuracy is critical. For most hobby projects, you'll mostly encounter gold or silver tolerance bands. They're more than accurate enough for everyday electronics work. So, keep this chart within arm's reach whenever you're building or repairing circuits. This chart is truly the key to reading any resistor you come across. With a little practice, you'll be able to glance at a resistor and know its value instantly. Let's try it out together and see how it works in real life. Let's decode a real resistor. Brown, black, red, gold. First band brown, 1. Second band black, 0, that's 10. Third band red, add 2 zeros, now it's $1,000. Fourth band gold, 5% tolerance. So, this resistor is 1,000 ohms, plus or minus 5%. In shorthand, 1K ohm, 5%. That's all there is to it. The color bands give you the value and the accuracy. Practice with a few more and you'll get the hang of it. It's a quick, repeatable process. Soon you'll read resistors at a glance. Let's talk about reading them the right way. When you pick up a resistor, you might wonder, how do you know which end to start reading from? It's a common question, especially for beginners, and getting it right is crucial for decoding the resistor's value accurately. Resistors may look simple, but their color bands hold all the information you need, if you know where to begin. The first thing to look for is a gold or silver band. This band isn't just decorative, it's called the tolerance band, and it tells you how precise the resistor's value is. The gold band means the resistor's value can vary by 5%, while silver means 10%. This band always goes on the right side when you're reading the resistor. So, to read the resistor correctly, hold it so the gold or silver tolerance band is on the right. Then, read the color bands from left to right, starting from the opposite end. This ensures you're interpreting the value in the standard way used by engineers and technicians worldwide. You'll often notice that the tolerance band is spaced a little farther away from the other color bands. This gap is intentional. It helps you quickly spot which end is which, even if the colors are a bit faded or the resistor is tiny. But what if your resistor doesn't have a gold or silver band? Don't worry. There's another clue. Look for a gap between the color bands. The bands that are closer together are the value bands, and you should read from the clustered side toward the gap. The gap usually marks the tolerance end, even if it's not colored gold or silver. If you're still unsure, try reading the resistor both ways. Use a resistor color code chart to check which value makes sense. Only one direction will give you a standard resistor value that matches what's available in the real world. This little test can save you from making mistakes in your circuit. In most cases, the gold or silver band is your best clue. Once you get used to spotting it, you'll be able to orient resistors quickly and confidently, whether you're building a project or troubleshooting a circuit. Getting the orientation right is essential. If you read the bands in the wrong direction, you'll end up with the wrong value, which can cause your circuit to malfunction or even damage components. Always double-check before soldering a resistor in place. The more you practice reading resistors, the easier it becomes. Lay out a few resistors, grab a color code chart, and test yourself. With a little repetition, you'll soon be able to read resistor values at a glance, just like the pros. Now that you know how to orient resistors, let's make memorizing the color codes easy. In the next section, I'll share a simple trick to help you remember the order of the colors, so you'll never get stuck again. When you're faced with a pile of resistors and need to decode their color bands quickly, memorizing the color order can feel overwhelming at first. But don't worry, there's a simple trick that makes it much easier. All you need is a catchy mnemonic, and suddenly, what seemed complicated becomes second nature. One of the most popular mnemonics is, "Big boys race our young girls, but Violet generally wins." It's a fun, memorable phrase that's been passed down through generations of electronics enthusiasts and students alike. Here's how it works. Each word's first letter stands for a color in the resistor code: black, brown, red, orange, yellow, green, blue, violet, gray, and white. Just say the phrase, and you'll instantly recall the order of the colors. Each color also matches a number. Black is 0, brown is 1, red is 2, orange is 3, yellow is 4, green is 5, blue is 6, violet is 7, gray is 8, and white is 9. This numbering system is the key to reading resistor values accurately. To help you remember, think of black always coming before brown, and green always before gray. Arranging resistors in this order on your workbench can reinforce the sequence visually. As you repeat the mnemonic, try to visualize each color in your mind. Picture the bands on a resistor as you say each word, and soon the sequence will become second nature. If that phrase doesn't quite stick, there are plenty of other versions to try. For example, bad beer rots our young guts, but vodka goes well. The important thing is to find a phrase that's easy for you to remember and fun to say. Don't be afraid to experiment. Write down a few different mnemonics and see which one feels most natural. Circle your favorite and keep it nearby as you practice. Practice is key. Say the mnemonic out loud as you look at real resistors, and write it down several times. The more you repeat it, the more it will stick in your memory. Before long, you'll be able to recite the color sequence without even thinking about it. Identifying resistor values will become a quick, confident process. You'll find yourself reaching for the chart less and less until you don't need it at all. That's the power of a good mnemonic and a little bit of practice. With repetition, you'll be able to decode resistors instantly, saving time and avoiding mistakes in your projects. This is a classic trick that every maker, engineer, and hobbyist uses. It's a shared secret in the electronics community, and it brings people together as they learn and build. So, lock your chosen mnemonic into your memory. Pin it above your workspace, or keep it in your notebook for quick reference. Now let's put it all together and see how easily you can identify resistor values using your new mnemonic. With this handy tool, you're ready to tackle any electronics project with confidence. Back to our example. Brown, black, red, gold. We know it's 1000 ohms, 5% tolerance. What does 5% mean? The actual value could be between 950 and 1050 ohms. For most projects, that's close enough. So, the full description is 1 ohm, 5%. That tells you both the resistance and the precision. This four-step process works for any 4-band resistor. Orient it, read the digits, add the zeros, check the tolerance. With practice, you'll do it in seconds. It's a core skill for any electronics project. Ready for your mission? You've cracked the resistor code. You know what resistors do, why they use colors, and how to read them. The 4 bands give you the digits, multiplier, and tolerance. You've got the color chart and a mnemonic to help. We decoded a real example together. Now it's your turn. Grab some resistors, old electronics, or a cheap pack. Practice reading the bands and writing down the values. Repeat until it's second nature. Soon you'll know values at a glance. No chart needed. This is a fundamental maker skill. Welcome to the club. Go build something amazing. The world of electronics is yours to explore. Can't wait to see what you create.